Our next talk is a collaboration talk with Anna from Spain and Sam from Brussels. Anna's a developer advocate at Auth0, has a degree in fine arts and a master's in international business, economics and management. Anna loves to code, especially with Angular, and a very active member in the community, organises regular meetups, and you might have heard of one of them called NG Spain. Sam is a Google developer expert who works as a developer advocate engineer at Auth0. Outside of Auth0 work, Sam likes to play around with Web Audio API and other exotic browser APIs. Sam, do I hear a Clubhouse alternative that's a PWA and works across all platforms coming out? This talk by Anna and Sam is on securing that app. So you've built your application. Have you thought about security? Don't worry, in this talk, we're all going to get up to speed. Anna and Sam are going to explain what cross-site scripting is, cross-site request forgery, SQL injection, and show you how you can defend your application against them. And so much more that we can learn from this talk about security. Over to you, Anna and Sam.
Hey everybody.
Hi everyone, and welcome to our talk, Secure That App. So we're going to be talking about how we can secure our applications today. And just before we do, Sam, could you tell us why we should even secure our applications?
I sure can. At least every 39 seconds, there's a hacker attack somewhere in the world. It takes about 196 days on average to identify a data breach and to resolve it. 75% of organizations around the world experienced some kind of phishing attack in 2020. I'm sure if you look in your own email account, you can find a phishing email or two.
But no need to fear, because Sam and Anna are here. So who are we? Well, first of all, I'm Anna CIDRE, and that's my Twitter handle, @AnnaCIDRE_. So feel free to reach out to me at any time. My DMs are open.
My name is Sam Bellen, and you can find me on the internet as @SamBego. And we're both developer advocate engineers at Auth0. If you've never heard about Auth0 before, that's okay. We're an identity as a service provider, which basically means that we try to make it as easy as possible for anybody to implement a secure authentication flow so you can focus on building your actual products. So today we're going to start by talking a bit about client-side attacks. There's a few of these attacks out there. You have cross-site scripting attacks, also known as Xss attacks. You have cross-site request forgery attacks, also known as Csrf attacks, clickjacking, and third-party assets abuse, where somebody tries to abuse a third-party asset to get access to your codebase.
So let's get started with cross-site scripting, which is also known as Xss. Now, an Xss attack allows an attacker to inject a script into the content of a website or application. Then when a user visits the infected page, the script will execute in the victim's browser. This will then allow the attacker to steal private information like cookies or account information, or maybe just to perform custom operations while impersonating the victim's identity. And there are three different types of Xss attacks. The first being reflected Xss, then stored Xss, and last but not least, Based Xss. So let's get started with reflected Xss. Reflected Xss is also known as non-persistent, and that's because it's when a temporary response from the server could be tricked. Now these occur when the attack is reflected off a web server. Could be via a search result or an error message or any response which echoes the user provided data back to the user. So that's why we call it reflected, right? So reflected attacks are normally delivered via a link and therefore require some amount of coercion, such as tricking the victim into clicking a link sent to them in an email, which is basically what Sam talked about earlier with the phishing attacks. So let's take a look at what this scenario might look like. So we have a baddie, and this baddie is going to find a vulnerable website. In this case, it's going to be a vulnerable website with a search engine. Now, the website search function receives the user supplied search term in a URL parameter. The application then echoes the supply search term in response to this URL. It might be in a paragraph. Now, assuming the application doesn't perform any other processing of the data, an attacker can construct an attack like this. And basically the URL is going to do the same thing, and it's going to inject that JavaScript. Now once the baddie has that URL, what they're going to do is grab it and send it to the user, maybe via a phishing attempt. Now like Sam said, if you check your spam folder, you're probably going to see some sort of phishing attempt, right? And if I were to go and click on that button, maybe what would happen to your user in this case is it's going to send a request to the web server. And as it's a vulnerable site, it's going to reflect that code back to the user. Now, just to note, no website should take arbitrary input from the user and then reflect it back to them, especially JavaScript code. Now, when the user opens the web page, the browser is going to start parsing that website, and then it's going to execute the JavaScript code that was sent by the baddie. Consequently, the data is then sent back to the baddie and through the code that the baddie injected into the URL. Now, this attack affects only the users that click on the URL. Next, we have Storedxss, also known as persistent. And this is when we add something to a database, and that data is going to live a long time. So let's take a look at, for example, commenting on an image on a social media platform. The data is stored for a long time, so what happens when other people see that comment? Well, the browser is downloaded and displaying that form from the web server. It could be the same process as reflected XSS in adding JavaScript code into an input field, but this time it's a comment. And unlike reflected XSS, this would then affect all subsequent users that visits the particular page, because once the user visits that page, the server is going to show all the comments that are there, including the one from the baddie, which was, well, JavaScript code. Then our browser is going to execute that code, and some data will then be sent from our victim to our baddie. So let's look at this scenario. We have the baddie, which again discovers a vulnerable website, and they're going to inject their malicious code there. In this case, in this scenario, as a comment. Then the server has stored this data, and so every subsequent user that visits this particular page on this particular web server, their browser is going to download it and execute the code, which includes the comment that the baddie did. Then due to this code, the user's data is sent to the baddie, normally in the form of cookies. But the most important thing here is that our victim's browser is coerced into sending the user's data to the baddie. Last but not least, we have DOM-based XSS. Now, DOM-based XSS happens, well, on the DOM. And a good example of this is an auto search function. So every time you type, the page you are viewing gets updated with the new results without requiring a refresh or being forwarded to a new page. This is where DOM-based XSS differs from the above. The server is not required for the XSS payload to take effect. Instead, the attacker abuses the runtime embedding of the user supplied data in the page. So let's take a look at this scenario. Again, we have a baddie who's going to find a vulnerable website, but this time it's going to be with a language setting. Now, what the baddie is doing is it's injecting its malicious code into the URL again. And when the victim clicks on this link, the browser sends a request for this page.html to evilcorp.com. The vulnerable website receives the request and provides the page, but the server doesn't process the malicious code. It's the client-side JavaScript that has access to the malicious code and runs it on the user's browser. Now, the original JavaScript code in the page does not expect the default parameter to contain HTML markup, and as such, it simply decodes and echoes it into the page, well, the DOM, at runtime. The browser then renders the resulting page and executes the attacker's script. Please note that the HTTP response sent from the server does not contain the attacker's payload. This payload manifests itself at the client-side script at runtime, so we're not including the server here. Right, So we've seen 3 different types of XSS attacks, and now we're going to see where these attacks can happen and where you need to be careful. So it can happen anywhere in your application where you have user-generated rich text, where you can drop an A-frame somewhere or put an object somewhere, anywhere a user has control over a URL, anywhere the user input is reflected back, like we saw before, query params rendered into the DOM, and .in HTML or eval, but we're going to focus on .in HTML because it's used quite often in JavaScript, and it's used for DOM manipulation. It actually returns the HTML content of an element, and because of the way that .in HTML can add text and elements to a web page, it can easily be manipulated to display potentially undesired or harmful elements with other HTML element tags. So we need to be especially careful there. So what solutions do we have? We must never insert untrusted data except in allowed locations. But most importantly, never accept actual JavaScript code from an untrusted source and then run it. For example, a parameter name callback that contains a JavaScript code snippet, because no amount of encoding and escaping can fix that. Next, we need to encode everything: HTML, JavaScript, attributes, CSS, and URLs. So if you insert untrusted data into HTML, JavaScript in your attributes, in your CSS, or in your URLs, make sure you encode them. Most web frameworks have already a method for HTML encoding or escaping for these sort of characters, so you don't actually have to do it. But you can encode the following characters with HTML entity encoding to prevent switching into any execution context, such as script, style, or event handlers. Next, we need to make sure we sanitize our HTML markup. There are libraries designed to do so for the job. Now, if your application handles markup, which is basically untrusted input that is supposed to contain HTML, it can be very, very difficult to validate. And encoding is also difficult, so that's why we really recommend libraries for this. Last but not least, we should remember that user input should be treated as values and not as code.
Let's move on to cross-site request forgery. Cross-site request forgery, also known as Csrf, takes advantage of the fact that a browser will save cookies or basic authentication credentials, and the browser will also attach those credentials or those cookies to any request with the same origin that's been made after the browser saved those credentials. So for example, in the case of a basic authentication, this is a case when you use the basic authentication header and the browser will show you this username and password login form. It's a native login form from the browser. Anything you enter in this form will be saved by the browser, and those credentials will be attached to any request after this when the request asks for basic authentication. The same thing goes for cookies. Once a browser has saved the cookie, it will attach those cookies to any request after it has saved the cookie. So for instance, in this scenario, we have a user that logs into their online banking app. And then the online banking app is going to verify the username and password, but if those username and password are okay, it's going to issue an authentication cookie, which will be saved by the browser. Now, for each next request that the user is going to do, the browser is going to attach that cookie, so the user doesn't have to log in with each request after they already logged in. And we can abuse this behavior that the browser attaches that cookie. For example, if we set up a little phishing site or a phishing email, we let the user navigate to a phishing site. And this phishing site might look exactly like our banking website, so the user doesn't even notice that they're on a phishing website. So they go to this phishing website, and this phishing website is going to do a fake request to the real banking app, and instead of maybe transferring money to a friend of the user, it might transfer all of the money owned by the user to the malicious third party, the baddies. So by forging a request, we will be misusing the behavior that the browser will attach that cookie automatically on the request to the banking app because the user has logged in previously, which means that we can steal all of the money. If you look at a little demo, here we have a demo where I set up a phishing site this Welcome to Super Evil Corp, which will show you a link to the real login website or the real login page of the banking app. And once you log in, you can continue. And we see that we have some money in my account and in Anna's account. But once I revisit this website, the website will now know that I'm logged in because I have that cookie attached to it, attached or available. So it will do a fake request to the real banking application with that cookie attached, and it will steal all our money. So as you can see, Sam and Anna both have €0. Mr. Robot has all of the money in from both of our accounts. So what's the solution? A possible solution can be to use a Csrf token. And a Csrf token is a unique, non-guessable token that will be issued with the first request. So this will be issued when you also issue that token. And every request that will use that token will also have to send that Csrf token to be able to use that cookie. So if you would do a request without this Csrf token, your backend will say like, hey, I know you're attaching this cookie, but I'm not sure if you're allowed to use this cookie because you haven't sent me that Csrf token, which means that only the original recipient of that token can use that cookie to do authenticated requests, and every man in the middle or third party or baddie that tries to misuse or forge a request without that token will not be able to use that cookie because he needed it in combination with that Csrf token. Another solution might be to use a token-based approach to do authenticated API requests. Things like OAuth or OpenID Connect, where you issue an Xss token and you'll use that Xss token as an API, as a bearer token with each request. Just because Xss tokens or bearer tokens are not automatically attached to API requests, so the browser will not automatically attach those to forged requests. Forging requests in modern browsers is a little bit more difficult than it used to be. For example, modern browsers do not attach cookies to cross-origin fetch requests by default. This means if you use a fetch API in JavaScript, you have to specifically tell the browser to attach the cookies if it's a cross-origin fetch request. You can do this by setting the credentials to include. By default, it's same origin, which means it will still automatically attach those cookies if it goes to an API. It does an API request to the same origin, but if it's cross-origin, you have to explicitly tell this. But if you do an HTTP form post by using the HTTP form element with an action and a method, the browser will still automatically attach that cookie, even to cross-origin resources. Also, modern browsers do not attach cookies when the access control allow origin is the asterisk, which means that it will allow all origins. You have to explicitly set a list, one or multiple origins that are allowed, and then the browser will attach the cookie. But if you leave it with the asterisk, the catch-all, the browser will not attach that cookie in any way.
Thanks, Sam. Now we're going to take a look at clickjacking. And clickjacking is known as a UI redress attack. So clickjacking is an attack that tricks a user into clicking a web page element which is invisible or disguised as another element. Now this can cause a user to unwillingly download malware, visit malicious web pages, provide credentials or sensitive information, transfer money, or even purchase products online. So let's take a look at what this scenario might look like. So we have our baddie again, and this baddie is going to create a page telling the user, for example, it might be a page that tells the user that they have a fine that they need to pay straight away, like alert, alert. Then they send this URL to the user, and what's the user going to do? Well, they're going to click on this URL, and it's going to send a request to the web server, and it's going to, well, what it's going to do is show the malicious page. Then the user makes the transfer and clicks submit. Now, when they click that submit button is when they're being clickjacked. And this can cause several things to happen. It could cause the user to download malware or redirect them to a malicious web page. It might provide credentials or sensitive information. Or in this case, it might even transfer that money to the baddie. So let's take a look at the demo. Typically, clickjacking is performed by displaying an invisible page or HTML element inside an iframe, and that's typically put on top of the page that the user sees. The user believes they're clicking on the visible page, but in fact they're clicking an invisible element in the additional page transposed on top of it. So what solutions do we have for this? The Xframe options HTTP response header is passed as part of the HTTP response of a web page, and it indicates whether or not a browser should be allowed to render a page inside a frame or an iframe tag. So if we call Xframe options deny, then we're saying that the page cannot be displayed in a frame, regardless of the site attempting to do so. Not only will attempts to load the page in a frame fail when loaded from other sites, but it will also fail when loaded from the same site. Now, if we want to if we specify same origin, you can still use the page in a frame as long as the site including in an A-frame is the same as the one serving the page. So we have deny for all pages and same origin for ones that are coming from the same page. Let's take a look at how this might look in Express, for example. So we have here helmet, and what we're saying is helmet.frameguard, and we're saying action same origin. So in this case, we're allowing sites from the same page.
Another thing baddies sometimes try to misuse is the use of third-party assets. Now, do you check the codebase of every external library you use, whether you install something through NPM, through Maven, through Composer, or any of the other package managers out there? Usually you just download the package and import it into your codebase because you trust those packages and you assume they only do what they say that they do. But maybe there's some malicious code in there that tries to steal credentials or cookies or local storage. So do you trust them, or should you trust them? For the most known ones, usually you can trust, but be aware that sometimes baddies try to misuse NPM packages or package manager external packages to get access to your code base. Also, it's not always as clear or easy to type the name correctly, so before you install a package, be sure to go to the documentation of that package and see the exact name. For instance, is it npm install alt0-spa-js, or is it npm install alt0/alt0-spa-js? In this instance, it's the bottom one, alt0/alt0-spa.js. But it can be something else. Is it JS SPA or SPA.js? By the top of my head, I don't even know this, so I have to look this up sometimes. And sometimes baddies try to misuse characters that can be mistaken for one another. For example, auth0 or auth0. It's auth0 because that's the name of the company, but it's very hard to distinguish an O and a 0, especially with certain fonts. In this example, the font does highlight the O with a dot in the middle of the 0 with a dot in the middle of the 0. So be aware that there's people trying to misuse the names of packages and try to create packages with a typo in the name deliberately, just so they can inject some code through those malicious packages. So let's look at an example. In this example, I have created a malicious npm package that just imports the alt0 package and does something extra as well. It also steals everything in your local storage. So if you click on the login button, we do get redirected to login. I didn't configure it properly for this demo, but we see that the functionality of the original alt0 package still works. So it still uses the original alt0 SPA.js SDK under the hood, but it does the extra thing where it also takes everything that I've saved in local storage and sends this to a malicious server, myself in this instance. So be aware that if you install a package, that it's the right package and not something that looks like a real package but actually is a malicious package. And just full disclosure, I did not actually publish this one on npm, it's just a demo. So what's the solution? Use reproducible builds with a log file. If your package manager supports log files, try to make use of those. npm does, yarn does. I think a lot of the other language package managers out there also support the log file. So you can lock down the versions of packages you want to use. So you can be sure that if in the future somebody tries to publish a malicious version of a library you use, you will not install that by default. You still have the chance to manually upgrade. Also use long-term support versions if you don't care about the bleeding edge features, if you don't always want to have the latest and greatest. Just because the least amount of times you upgrade packages, you have less amount of possibility to install something that's a malicious package. Also, you can write tests to assert that only expected requests are sent out. So if you have an application that sends certain API requests, you can test the application to send those API requests. But if any other request goes out, that application or those tests will fail. So you might see that certain malicious request, maybe stealing your tokens or your credentials, go to a malicious server. So if you write tests that assert certain requests, make sure that you also check that no other requests are going out. You can also make use of the integrity attributes to a script tag if you're using a CDN, for example, so that the browser will verify the integrity of a package. And how does that work? You have the regular HTML script tag where you pass along a source, maybe cross-origin, but you can also pass along an integrity attribute which will start with the hashing algorithm, in this case SHA-384, and then the hash of the JavaScript file we expect. So you first need to create a hash of the JavaScript file. Once you have that hash, you can pass it along as the integrity attribute, and then the browser will check that hash for you. So if something has changed in this JavaScript file, either in transfer or by a man-in-the-middle attack or something like that, the browser will say like, hey, the hash you expected to be does not really match with the contents of this JavaScript file, so I will not load this. And the last thing you can do is support bug bounty programs, especially for important open source projects, because the more resources they have, the more time and effort they can put into making sure that their open source libraries and projects are secure and up to date.
Thank you so much for listening to us today. You can find our Twitter handles there on the slide. So if you have any questions, feel free to reach out to either one of us. Thank you again. Bye.
Anna, Sam, thank you very much for that amazing talk on securing our applications. It was absolutely fantastic. Fingers crossed we got a few audience members left who aren't running off right now to secure their applications. Please do, everyone watching along at home, join me in giving them a huge, around the world, round of applause. So we're heading into another break now, which means it's time for another cup of tea, maybe a sandwich this time. I don't know what time of day it is where you are. If it's sandwich time, go and grab one right now. If you are on GatherTown, please do visit our sponsor booth. There's some really good offers there, and watch out for the games that are dotted around the arena so that you can get to know your attendees over a game of Tetris or other cool and classic games that are built into the platform. Don't forget, let us know how you're finding the talks using the hashtag CIDRESS2021, as well as keep the comments in on YouTube. See you after the break.
And we are live. Thank you very much for that fantastic talk. It was our first duo session of the day, and I hesitate to say it was twice as awesome as a single session. Would we agree?
I think we can agree on that.
Yeah.
Excellent. So where are you two tuning in from today?
Well, it says Madrid, but that's not quite correct. I'm actually in Santiago, which is the northwest of Spain.
Okay.
It's actually the rainiest city in Spain, which is a fun fact. But luckily enough, it's not raining today. So there you go.
Now I'm calling in from Belgium, which is the rainiest part of Europe, I guess. But it's not raining either here today.
Oh, wow. Sounds like that's par for the course, a bit of rain in Belgium.
Yep.
Excellent. So I've got a question of my own to kick us off, and this is for my own sanity more than anything else. Why do we as developers even have to think about some of these security things anymore? Why haven't the browsers just gone ahead and solved it for us?
That's a very good question. And during the talk, we've mentioned a few times, I think, that browsers are doing certain things or are making it a little bit harder to prevent certain attacks. But the reality is there's so many attack surfaces and so many different ways that malicious people are trying to misuse code and websites and browsers that it's just impossible to close all gaps. And if the browsers would do that, these people would find other ways to misuse whatever they want to misuse, I guess.
Yeah, and I just want to extend on that. Like, for example, on some XSS tags, if the browsers try to like cover all of those, then our applications probably wouldn't work properly either. So we have to say what should be done and what shouldn't be done.
Yep.
So the browsers know.
That's a really, really good point. That's a really, really good point. Yeah, nothing would work if we tied everything down, would it?
No, we'd like to keep a bit of freedom on the web as well, especially as developers. We want to develop what we want to develop instead of working between these fine constraints of possibility.
Okay. We had a question come in from, and I'm going to butcher this name, so I apologize now, Levlin. And it's a question for you, Anna. Do you have any good HTML markup sanitization libraries that you would recommend or suggest people look at?
Well, the good thing is that the OWASP documents has us covered. So there's a cheat sheet that you can go to. I can share the link in gather.town later. And it has it for, depending whether you're looking for a Java HTML sanitizer or a Ruby on Rails one, they have them all listed there. And yeah, it's depending what you're looking for, really. So.
Nice. Nice. Are there any other kind of libraries that can support HTML sanitization and make things more secure?
Yeah, but like Sam said in the talk, you really have to be careful with what you use when it comes to third parties. So take Sam's advice from the talk and be careful and just follow. I always would use the ones from OWASP.
Yeah, I guess they've been vetted and checked and
Exactly.
definitely the ones to use. Okay, so we're still waiting for some more questions to come in from the audience, but I am going to ask you right now if you could turn it up to 11. And do you have an 11th top security tip to give to our audience? Or is 10 the ceiling for this?
I think we ended this presentation with a slide which didn't make it into the actual recording, which said, turn off your internet and close your door.
Yeah, that's pretty much it. And we just pulled out like the most common client-side attacks, but you also have server-side attacks. And there's a lot of security issues. We try to cover the most important ones, the most vulnerable ones.
Okay. So I'm asking now as somebody who's not very educated in security ways, which I'm sure a lot of people watching along are. Are there any libraries that you know of which can help spot the implementation of potentially vulnerable things at the time of writing code, rather than having to test it live or test it on production? Is that tech there to support us?
There are some linters which might scan for common vulnerabilities, let's say, but I cannot come up with a name here on the spot.
Yeah, and a lot of frameworks do a lot of the work for you already, so that's also really good.
Yeah, I suppose that writing in frameworks, you're kind of abstracted away from a lot of this stuff because it's been implemented as part of core, I would guess.
Yep, indeed.
Exactly, yeah.
Oh dear. But it's I don't know. Is there some fun to leaving security holes in? So if you've got a little side project, maybe leaving some holes there for people to get into so you can realize what they can do.
You could create a game for any potential hacker to just find their way through your application, and in the end just be like, ha, gotcha, this doesn't lead to anywhere. But yeah, that would be a fun game, actually. Something we could try out once.
Yeah, as long as other people's data isn't being compromised, it's
Indeed.
fun.
For a side project, that would be a fun thing to experiment with.
I think we are seeing conference-driven development in action here, folks.
The best kind of development.
So let's brainstorm this. What kind of game would it be?
I think you would just try to figure out a common path that a hacker would go through your app and tries to penetrate your application from front to back end and then down all the way down the rabbit hole that a hacker potentially could go. But try to constrain all of the exits out of that path. So the hacker kind of has to follow that predefined path. And then in the end, you'll be like, ha, gotcha. Something like that. But which means that you have to be aware of all of the security flaws and fill them all in except the ones you want the hacker to find.
Yeah, then it shows a screen at the end that says you've been hacked.
I mean, it sounds like it does sound like a nice challenge and a nice learning tool for somebody.
Yeah.
You know, somebody who's just getting into this kind of stuff. It'd be
You've just wasted my weekend.
I have a habit of doing that, to be honest. It's normally my own, but you know. So what is next up for you in terms of this security stuff? So for me, I'm questioning why you're so interested in this kind of stuff. Where did it start, and where is your security journey going to take you in the future, do you think?
Well, for me, being part of Auth0 obviously plays a massive role in it. And I personally wanted to get more familiar with security, especially working for a company that is specialized in identity and security. And I needed an ally. So I was like, hey, Sam,
She dragged me
learn
along.
about security. And that's pretty much how it all started.
Yeah, and maybe it's also something we can mention is that when we were coming up with an idea to build this talk, we actually had two IDs for this talk and another talk, and that other talk would go more into detail on anything you can do before you start actually building your application, because this talk, it talks about common vulnerabilities and how to stop them. But before you write your first line of code, there's also things you can do and think about that would prevent certain flaws in your application later on. So we might take it down that route as well in the future.
Yeah.
Okay, that's exciting. Anything you can solve before you've written a line of code is worth doing, right?
Yeah, it's usually the best.
Yeah.
So this next one comes from Eileen, and it's not really a question, it's more flattery. Thank you, Anna and Sam, for such a great talk. It was easy to follow and understand.
We like those kind of questions or statements.
They're the best kind.
That's really great. Thank you, Eileen.
Thank you.
So we've got less than a minute left, so I've got a couple of rapid fire questions for you. Anna, if you answer first, and then Sam, tabs or spaces?
Do we really need to get into these?
Yeah, I'll try to start a little flame war.
Spaces.
Yes. Sam, are you going to go with the right answer as well?
Spaces all the way.
Excellent. And front end or back end, Anna?
Front end.
Front end.
Front end.
You've both given the correct answers. Congratulations.
What do we win?
You win a very quick exit out of this Q&A call.
Okay.
So we are wrapping up here. One final time to say thank you very much for such a superb talk. I'm looking forward to going back and watching it again and making even more notes because we were a bit busy this time. But Anna, Sam, thank you very much for your time, and hopefully we'll see you throughout the conference in Gather.
Thank you for having us.
Yeah, thank you.
Our pleasure.